for coming with us to do some science today. I'm Michelle Jedlicka. Most of my school friends call me Jed. This is Mrs. Aiken. Hi. We are both high school science teachers, and we are here to do some fun experiments with you today. Some of them will tell you can do at home, and we'll tell them how you can do them at home. But then some of them are a little less safe, so you probably should not try them on your own, even with mom and dad. How many of you right now are really missing your teachers and really missing being at school? I know, we are too. We miss our kids so very much. Just know that your teachers miss you very dearly and cannot wait until they get back to see you again. And we appreciate you coming and joining us and letting us get to be your teachers for a little while. Mrs. Aiken?
So, you're going to notice today that we're wearing some lab coats. And if you see any pictures of our feet, we're wearing some closed-toed shoes. That means our toes are covered, our legs are covered for safety. And then finally, you're going to see that we're looking really nice in some lab goggles, because in the total sum of things, it's really important to be safe, even if you're doing things that just involve stuff from home. So, safety first. All right, I'm going to turn it over to Miss Jedlicka and Cortland.
Nope, Landon.
Landon.
Okay, so how many of you like to eat ice cream? I know, me too, it's super yummy. Have you ever made ice cream at home? Okay, well, usually when you make ice cream at home, you need an ice cream maker and things like that. Today we're going to make it a little bit easier. So I just have a plain plastic container. Could be any type of plastic container that you have. And what I'm going to do is I'm going to put in it some milk. If you have whole milk or even heavy cream, that works better. It just makes the ice cream taste better. I'm going to put in sugar. This recipe calls for about 1/3 of a cup, but you could do more or less depending on what you like. And then I'm going to add vanilla. Oh, about, depending on the size of the cap of your vanilla, maybe a capful, maybe about half a capful. I don't always measure real well when I'm cooking. So I'm going to screw this lid on nice and tight. And this is one you can do at home. This is lots of fun to do at home. So I'm going to shake that up and I'm going to put it in here. And what I have in here already is some ice and water. And go ahead. One of the things that I'm going to add to it is something called rock salt. How many of you live somewhere where it freezes and gets really cold and sometimes there's ice on the road? Have you noticed that when it gets cold, sometimes they'll put some stuff on the road that's either salt or sand to keep the road from freezing when it's rainy or snowy? They do that because what the salt does is it makes it so that it has to be colder before that ice is going to freeze. So what we're going to do today to make our ice cream is we already have our water and our ice. I'm going to add to it a handful of rock salt. This isn't anything special. You can get it from your local grocery store. But what that rock salt does for our ice cream is it makes that water and ice mixture that I have in there stay super cold and stay colder while the ice is melting so that it makes our ice cream. I happen to have 2 containers that work really well inside of each other. Another option, if you don't have 2 containers that you can do this with, is just to put the ice cream mixture in a Ziploc baggie, like a normal Ziploc snack baggie or sandwich baggie, and then put the ice and water and salt in a gallon-sized Ziploc baggie, but just make sure that baggie on the inside with your ice cream's closed super tight. Then I'm going to close this, and Landon is going to be our ice cream maker. He's going to make a whole lot of noise, so he's going to go in another room. But he's just going to sit there and spin this around. If you were with a sibling or something, you could even roll it back and forth if you were super careful about it. But he's gonna spin that ice cream and make it cold. Okay, Mrs. Aiken?
Boy, is he loud. All right, so our next experiment is gonna be something called the pH rainbow. Now, I'm gonna be honest, this is not gonna be one that you can probably do at home. You don't really have the things to do this, but we wanted to show you some really cool chemistry today. So what I have here is this tall piece of glass. This is called a graduated cylinder. And my graduated cylinder is currently full of water. So this is just plain old water. I also have something called universal indicator. Universal indicator is something that's going to change colors when a reaction happens. And I have a compound called sodium hydroxide. Now, safety first. Again, you're also going to see me using some big plastic gloves because in this cooler we have something called dry ice. Dry ice is actually frozen carbon dioxide. The same stuff that you breathe out, that same gas, is the frozen form of this. So here we go. We're going to be adding a little bit of our 1 molar sodium hydroxide into our container. The next thing I'm going to add is the universal indicator. Now the universal indicator, as I said, is going to change colors. But what you're going to see when we get started is that it's going to be this really nice dark purple color. And I'm going to stir that so that we get it mixing all the way down the tube. We put this white paper in front so you can see that color. All right. Maybe not all the way to the bottom, but it's getting really, really close. All right, so that purple color tells us right now that a certain compound, that sodium hydroxide, is in our container. What we're gonna do now is add a little bit of that dry ice. Now, dry ice is a lot of fun, but you never wanna use it without an adult around. It can only be purchased by adults, so, you know, it might have to be something that mom and dad grab for you at the store if you ever wanted to see it. All right, here we go. Dropping in a piece of our dry ice. Now you're gonna see it's gonna start making a lot of bubbles. Let me put that white paper behind it again so you can see what's happening to our color. So you can see those bubbles rising. Those bubbles are the dry ice, a solid, forming a gas that's rising through and coming out the top. We can see that that gas is very heavy. It's coming out, sinking down the length of the tube. Now you're also going to notice the color. That color is changing as we watch. You can kind of see we started out at a really nice dark purple, and we're going to see that color start to change in just a little bit. While it's changing, I'm going to add one more piece of dry ice so we don't run out. So now we're really bubbling and making some vapor. Again, that vapor that's coming off. Just so you know how it feels kind of cool to the feel of my fingers. There's nothing dangerous about this vapor, but you wouldn't want to breathe it in for too long. That could be dangerous. All right, so seeing our color kind of going to a nice purplish blue now. We're now at a color that's really nice and a true blue. And here we go, blue kind of teal color. We're heading on our way to green. So you might notice this is going in the color of the rainbow. We've gone purple, blue, green, and now we're forming a really nice kind of greenish yellow. Guess where we're headed? Oh yeah, we're headed to yellow, folks. Now you might want to ask, wow, we've made it all the way to yellow. Is it going to go to red? Unfortunately, no. This dry ice is forming an acid in this water as it turns into a vapor. So the acid that's formed is called carbonic acid. It's the same acid that's sometimes used in sodas to make them taste kind of tart. And in this case, this is about as yellow as it's gonna go. We're not gonna go to orange or red. But what we could do, if we got really excited about things, is turn it back to purple by adding that base, adding that sodium hydroxide. So again, you'll see it kind of cycle through all those pretty colors, and we can just keep doing this until this runs out or the dry ice does. All right, hope you've enjoyed a little bit of pH rainbow, and now I'm gonna turn it back over to Miss Jellica.
Okay, so I'm going to talk a minute. Cortland is one of our helpers that's here today. So what we've done is in that plate that you see in front of him, and this is one of those that you can do at home. And that's why he's helping with it. So all I've done here is I have vinegar with some yellow food coloring in it, and then vinegar with red food coloring in it. And I'm going to add a little bit more vinegar in this cup with some blue food coloring, and this is just plain vinegar that I bought at the store. I do have my glasses on because vinegar can hurt my eyes. Really, you need to take any safety precautions that you would for dyeing Easter eggs. Cortland is going to also wear some goggles before he starts playing with it. How many of you have ever heard the words acid and base in your science classes? Usually, unless you're at least older elementary school, you probably haven't heard those words. So what Miss Aiken did with the colors, they have to do with acids and bases as well. But when we have just plain baking soda, that's something called a base. Bases are why soap is slippery. That's where you've seen, usually when you interact with soap is probably the most common base you use. Things like vinegar, which makes, vinegar is actually what makes pickles pickles, or even the sourness in an orange or the sourness in a lemon or lime is from acids, okay? So the specific acid in those citric fruits is citric acid. That's why we call them citrus fruits. But what's really cool is when you combine acids and bases in a safe way, they can do pretty cool things. So Cortland is going to take an eyedropper bottle, and like I said, all of this is colored vinegar, and he's just gonna drip onto that baking soda. And you can see that he is doing science, because as that acid and base meet each other, we get the nice pretty bubbles because they're reacting. But also he's kind of making an art project on the baking soda. So this is one of those that you could definitely do at home. You would need to take safety precautions that are similar to when you're dyeing Easter eggs, because it's a similar process with the vinegar and the water. But it's a lot of fun, and he can make some pretty cool designs on the baking soda, and we'll give him a few minutes to do that while we show you something else, and then we'll come back and see what all he's done. Ms. Aiken, are you ready for your next one?
Almost.
Okay. We'll watch Cortland another couple seconds while you're setting that up. Okay. Nope. We still have all the ice cream makings.
All right, so our next experiment is also going to involve some dry ice. So again, got my goggles on, got my dry ice in the cooler, and I've got my glove. Now in this experiment, what you're gonna see is that we have a nice long ramp set up. We have a candle on the ramp. So I'm gonna put my candle right here, and I'm gonna go ahead and light the candle. Just using a regular candle lighter. And I'm gonna take my dry ice and I'm gonna be putting it into a container of water. Let me go grab that real quick and I'll be right back.
So that's just a normal candle that she has burning. The piece of plastic is just a regular PVC plastic. It's actually a gutter that we put together to look like that so that we can do some science experiments with it. Okay, here comes Miss Inky.
Okay, so I've got my beaker full of water. This is just tap water, nothing special about that. I've got my dry ice, and I'm gonna get a piece. You're gonna see a very similar thing happen in this experiment, but we're gonna do something a little bit different with it. So here it is. While I hold it in my hands, you can probably see that it is wanting to make a little bit of that gas, but when I put it in the water, that process is going to be much, much faster. So I want you to watch the candle. Watch the candle. I also want you to watch what I'm fixing to do. Watch the candle. Now, I don't know if you can see, but the candle himself, he's kind of looking like he's struggling a little bit. He's having a hard time staying lit. So I'm going to get a little bit closer and let's see if we can put the candle out with our dry ice vapor, our CO2 vapor. Here we go. And he's out. And I never had to blow on it. I never had to knock out the flame itself because the dry ice, this vapor that comes out, this carbon dioxide, is actually the same stuff that's in a fire extinguisher. Fire extinguishers contain carbon dioxide and they use that to help put out flames. So when you see the movies where they set off the fire extinguisher, what it's really putting out is carbon dioxide. It's a compound that makes that and puts out the flame. So that little bit of science is what saves us if we're ever in an emergency like that. Okay, Miss Judlica, are you ready for our next experiment?
I am.
Okay, I'm handing off the goggles. So we don't forget our safety.
Nope. And Cortland is going to come back and help me with this one in just a minute. This is one you can do at home with mom or dad's help. There aren't any chemicals in this one more than what you would have in your kitchen. All of this stuff came out of my kitchen this morning. So all I'm doing is pouring milk into just a plain pie pan. Big enough probably.
Yeah.
If you use whole milk, it tends to work better than if you use skim milk or 2% milk. And Cortland is going to take each of these dropper bottles and just drop 1 or 2 drops of just very, very gently onto the top of the milk. So if you've ever, how many of you have ever seen a bug like a mosquito stand on water? Yeah, it's kind of cool. They can stand on water and walk on it. Well, that's because the water has something called surface tension. Milk also has a certain amount of surface tension, which is why, go ahead and put the blue here, these droplets of color are staying up on top of that milk instead of sinking down into it and mixing. We got to take the lid off. Okay, and these are just normal food colorings. Nothing special about them. Put it out further. There you go. Okay, so Cortland has now kind of dripped a few colors around for us. And I'm just going to take regular old dishwashing soap, nothing fancy about it, and I'm going to get just the tiniest little drip of it and put it in the middle. That little drip broke the surface tension of that See, I might need another drip. That's good. And now those colors are starting to flow. If you're patient, it will start flowing more and more. And all we started with was 6 drops of color and 1 little bitty drop of dish soap.
So confused.
That dish soap broke the tension, the surface tension in that water. So now, if a bug, now all of the colors are mixing instead of staying separate. Okay, that tends to work better. This one didn't work as well as usual, but it works better if you put the color a little bit closer together and you get a nice flowing color. You can even, if you do it in a glass one, see it on the sides. But now we are going to go back to Mrs. Aiken.
So the next thing we wanted to show you is a little experiment called the MOM demo. Now, a long time ago, you probably don't remember this, there was a commercial for Milk of Magnesia, M-O-M, MOM, and it said, the best thing when you're sick is MOM, and they meant this medicine. Now this medicine, I'm gonna go ahead and add this medicine to a little bit of water. I also have a little bit of ice in here. I'm actually gonna use our paper towel and wipe the side of the container so you can see really clearly through there. And I'm gonna add about a dose of the MOM, of the Milk of Magnesia. Now you're gonna see as I pour this, it's very thick and kind of looks like milk. That's where the medicine got its name, is it looks like milk, but this is actually made of a compound called magnesium hydroxide. Now I'm giving it a stir with this glass stirring rod. And also into my beaker, I'm gonna use an old friend that we saw earlier, a little bit of that universal indicator. And I'm gonna add enough so that we can get a nice bright color. And you're gonna see it's gonna turn purple. Now, I don't know if you remember from earlier, but when it was purple, what was in there? Oh yeah, it was a base. Bases tend to make this turn purple. Now, this medicine is taken if you have a sick tummy. Does anybody know what acid is in your tummy? It is an acid called hydrochloric acid. And if we have too much of it, it can make us feel bad. So what I have here is that same acid that's in your tummy, this hydrochloric acid, and I want to show you how the medicine fights the acid in your tummy to make you feel better. So I'm going to add a little bit. And I'm going to give it a good stir. Wow, check out that color. Now, you can see we have a nice bright pink color. What? And it went suddenly all the way back to blue. So what the heck happened? Well, the acid from our tummy reacted with the base and made it so that our tummy didn't hurt anymore. Now, if we had even more acid, we could see that that process might repeat itself. Pink. And if we wait long enough, we might take it all the way back. That may have been a little bit too much tummy acid. Sometimes it's kind of hard to figure out quite how much we need, but I wanted to show you. Remember how, oh, there it goes. I always don't wait long enough. We can see that color's changing back, but I want you to notice, remember how thick and milky this was? Now we're starting to see that we can see through this. You can see my fingers behind it because all that milkiness was reacted with the acid and used up. And that's what the medicine does. It makes us feel better because over time, it uses up the acid and keeps our tummy from hurting.
All right, thank you, Miss Aiken. Okay, so I told you that after a little while we would come back and look at the artwork that Cortland made. This is what he made with the vinegar and baking soda. Remember, every time you put that drop of baking soda on there, you get the nice pretty fizz. So you're getting to do science and art all at the same time. And this can be done with things that you can find in your house. So now we're going to check in with Landon, who's been off in another room trying to make ice cream. And he's going to open it up, and normally you would want to have a towel or something around you just because it gets a little bit messy. But all Landon's doing, he took out that container that he made his ice cream in earlier, and hopefully he's going to be able to unscrew it.
Nice.
You need some help?
I think so.
Here, Courtland, can you come hold the camera? Sorry guys, can you tell we're not professional video people? Okay,
Oh, I got it.
so Landon's going to undo that, and we didn't have quite enough time on our video today because we were limited on time. But if you look, that milk that we put in there a little while ago is well on its way to freezing and turning into ice cream. Landon, you want to taste it before you put it back in there and work on? Does it taste like ice cream?
Yeah.
Yeah. Okay. Oh, don't eat off of the same spoon. So Landon's gonna put that top back on there and start stirring it again. But while these two silly ones do this, we are all gonna go outside and watch a really quick demo that is not safe enough to do in the house. This one gives us a big boom. So we're gonna quickly go outside. Sorry. And Miss Aiken is out here. And as you can see, she has a giant water bottle. Go ahead, Miss Aiken.
All right, so what you're gonna see for our very last, we figured we better end with a big bang. And so first off, we're doing this outside. The fumes from this, definitely not safe. The experiment itself, definitely not safe. You should never, ever, ever, ever do this one at home. But to increase our safety, we've taken this empty water bottle. You've probably seen this. These are the refill bottles if you get bottled water at home. We've wrapped it in some tape so that we reduce the likelihood that it might crack or shatter. Now the first thing that I'm going to do is I'm going to take some ethanol. Ethanol is an alcohol. It's very similar to rubbing alcohol that you might use if you had a cut or something that you might need to disinfect. And I'm going to add a little bit of that ethanol, and then I'm going to take the bottle because it is dangerous, and I'm going to put it out of the way. Now, there's just a little bit of ethanol in here, but we don't need much to make this one work. So I'm going to swirl around my bottle, and the reason I'm swirling around my bottle is to make the ethanol turn into a vapor. Remember earlier we said that gases come from or can evaporate from a liquid or a solid. We saw dry ice or solid CO2 turn into a gas. This liquid is now turning into a gas. So I'm rolling it around to make it turn into a gas. And right now I can smell that it's starting to come out of the mouth of the bottle because it is turning into a gas. So I want to make sure you get a good show. So we give it a few more spins.
And remember, this is one that you do not ever want to do at home. This one's dangerous, and you should only ever do this if you are a scientist and you are trained and all of those things. This is not one that you can do at home.
Definitely not. Okay. I don't see any more liquid rolling around inside, so that tells me we're just about ready. So I'm going to use a pair of tongs so that I can get far away from it. I don't want this to burn my hand. I'm going to use a little piece of wood. This is called a splint. And I'm going to turn it downward like this and set the end on fire away from the container. Now this does go pretty quick, so if you've only been halfway paying attention, you need to pay attention now. All right, make sure I get my flame ready. Okay, Miss Jedlicka, are we ready?
Ready, I'm backing up.
Okay, well, keep it lit. Sorry guys, it's a windy day. Here we go. Oh, can't keep the flame lit. Ready? And 1, 2, 3. All right, now, just to show you, Landon, or Miss Jedlicka, come take a feel. Tell us how the container feels.
Ooh, it's hot. That was a quick fire.
Nice and hot. And the other thing that's in here, we'll see if a little bit will come out. May not be.
Nope.
May be too
Not
hot in
today.
here. But sometimes this reaction does produce some water, and that water will collect in the container and come out. We really hope you've enjoyed your time with us today. We can't wait to get back to our classrooms and back to our students, and I know your teachers feel the same.
Thank y'all for coming and hanging out and doing some science. Bye. Have a good afternoon.